Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. We've got step 1, step 2, step 3. We've even got a step 4 today. And your challenge is to predict the number of squares in step 5. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, so this is an interesting looking one. I guess what I noticed first is we've got a blue square and a red square, and then it looks like maybe they're expanding as squares. So this could be a 4x4 blue square and a 4x4 red square, except where they overlap, it all disappears. And that seems to be going on in step 3. Could be a 3x3 and a 3x3, but where they're overlapping, it disappears. And then a 4x4 and a 4x4, but where they're overlapping, it disappears. That's really interesting. So using that intuition, I would say we'd have a 5x5 and a 5x5. And wherever it overlaps, they would disappear, right? So, how would I draw this? So 5x5 and a 5x5 coming in like this. So what would that mean? We'd have 5 along here. 1, 2, 3, 4, 5. And then, let's see, you've already got the 1 there. So 1, 2, 3, 4 more there. And then the same pattern would repeat over here, 5 and 4. So you'd have 9, 9, 18. So it looks like 18 for step 5. I think that's my prediction. This drawing is a little hard to see that on, but that's what I'm thinking. Now, it looks like these are squares and they're overlapping. And my question for you right now is this a quadratic pattern? What do you think about that? I think I'm going to analyze the numbers, and we'll take a look at it from that direction first. Definitely you can see this pattern as squares, overlapping squares, but we're making a whole bunch disappear, right? So in this 4x4 overlapping, we've got a 3x3 section that just disappears from both of them. But let's analyze the numbers. So we'll do the step number in a chart and the number of squares. So in step 1, they're just those 2. In step 2, that's 6. In step 3, 10, and in step 4, 5, 6, 7, 14, and in step 5, we're predicting 18. And now if we take the differences, 6 minus 2 is 4, 10 minus 6 is 4, 14 minus 10 is 4, and 18 minus 14 is 4. We're definitely getting a constant in our first set of differences, which means this is linear. This is not quadratic at all. I guess we could have thought of this as well, let's think about it from step 4. We've got a 4x4 square, so that's x squared, plus a 4x4 square, so plus x squared, but we're subtracting this 3x3 square, so that's x minus 1 squared, but 2 of those, and we're subtracting it. So this could be an equation. It's obviously really complicated and more complicated than we need because the numbers here are telling us this is a linear equation. So let's come up with a linear equation and then maybe we'll do the math on this and see if it actually comes out to be the same thing. So our equation for a line is y equals mx plus b, and this constant, this rate of change of our pattern is going to be our slope. So y equals 4 times x. And then to determine what that b is, we try it out. We try out this stem of the equation with step 1. So y equals 4 times step 1. 4 times 1 would be 4, but we've got 2 here. So we'd have to subtract 2. Subtract 2. And that gives us 2. If we try y equals 4 times step 2 minus 2, 8 minus 2 would be 6. That's what we're getting. 4 times step 3 minus 2, 12 minus 2 is 10. That's what we're getting. So it looks like this equation, y equals 4x minus 2, is the right equation. I'm just curious if this is going to come out to be the same thing. So I'm gonna do some simplifying. First of all, x squared plus x squared would be 2x squared. And then we're going to subtract this big thing, but let's work on this. Let's FOIL that out. So we've got that 2 times and x squared minus 2x plus 1. So I think I squared the x minus 1 correctly there. And then let's go ahead and distribute the, well, actually, let's distribute the -2 through. We'll attach this negative sign here. So I've got 2x squared, and then it's going to be minus 2x squared, right? So -2 times x squared, right? Now -2 times -2x would be a positive 4x, and -2 times a positive 1 would be a -2. And would you look at this? We have 2x squared minus 2x squared. That's 0. And what we're left with is 4x minus 2. I find that pleasing when you interpret a pattern in a couple of different ways and the equations come out to be the same. That's very satisfying. Well, we've only got one thing left to do, and that is to calculate how many in step 43. And we'll do that by plugging that into our equation. So y equals 4 times 43 minus 2. And let's see, 4 times 43. 4 times 40 is 160. 4 times 3 is 12. And so that's 172. But we've got the minus 2 still. So it looks like 170 squares in step number 43. Well, how did that go for you? I'm curious to hear about this one. Did you see this as a pattern of squares, or did you just count the numbers and figure out it was a linear pattern and not a quadratic right away? Let me know. Thanks, everybody.